Hey everyone, whether you are novice or expert in the field of machine learning, confusion metrics might have confused you some point in time. If you are novice, then the questions which are marked here as white color might be your concern. If you are expert, the topics which are marked here as yellow color might be your concern. The sources of these concerns are two. We don't discuss this topic with our friends or colleagues enough because this is a very elementary subject and therefore we tend to bypass it and then go to the advanced topic. The second source of confusion is that the confusion metrics are normally taught in the academic context or the tutorial and then abruptly stops at binary classification, whereas in practical field you will be applying them in multi-class classification. In this video we are going to clarify all those aspects. Confusion metric starts with the actual data. For example, in this case we are saying that there are 10 example data that we have which are actual data, and then we want to divide them into two parts. One is the positive class, which is often the concern, the matter of interest. For example, it could be spam, or it is whether a disease is there or not. That's called the positive class. Then we have the negative class, which our sample has been divided in 30 and 70% ratio. Now we want our model to predict the positive class first. So when we are predicting them, the model will have some confusion, it will have some error. First it will predict the positive class truly, which is called the true positive, as it is shown here. Out of 3, it has predicted 2 as the correct value, and then it will predict the positive class itself, but there will be certain wrong or the error in the prediction, which is called the false positive. They are false because they truly belong to the negative class. So that's how the model gets confused, and that's how the name of this matrix is confusion matrix. It's the confusion for the model, not for us as of now. So this total, the prediction is 5 for the positive class, although the true class, which is represented by the row, is actually 3. So that's how the error has come into picture. The error here are 3, which is false positive. Now you also want the model to predict the negative class, and there also you will see there is some error which is happening. In this particular case, you have the model have predicted the positive class wrongly, one of them, therefore this is false negative. You have asked the model to predict negative class, but one of the positive class has been predicted as negative, that is how it is false negative, and the remaining whatever is there has been predicted as the negative class, which is true. Therefore that also is totaling up to 5. You can see how the model have confused in terms of these two values, where you have error in model prediction, and that's the source of confusion for the model. Now using this matrix, lot of evaluation metric can be formulated. We'll focus on those which are very important for most of the industrial cases. These two errors are also known as type 1 error and type 2 error in some places. Now if you look at the source of confusion for us, human, not the model, one of the source is this, the different format through which this confusion matrix can be presented. Most of the academic context, you will see it is starting with the first quadrant as negative and negative, true negative, whereas what we have started here, which is more aligned with the coding and the practical tools, are the first quadrant is basically TP, and you can see there are many other formats through which the confusion matrix can be presented. That's also creates some source of confusion there. You should therefore keep in mind that when you want to align with the, let's say, scikit-learn code, we stick to what we have presented. The rows presenting as the actual, and the column which is presenting as the prediction, and the first quadrant is basically positive positive. Fair enough. Now let's see the first evaluation matrix which can be formulated from here is the accuracy. Sometimes it serves a purpose. For example, in NLP cases, when we are interested only about question answering, whether the question is wrong or right, so that can be very easily calculated from the correct prediction vis-a-vis as against the total number of prediction that we have done. Accuracy serves a good purpose there. For example, in our cases, this diagonal predictions, which is this TP and the true negative, wherever we have true, creates the numerator, which is the correct prediction. Both are correct. And if we take correct and wrong all prediction, that becomes 10, therefore this becomes 60%. But often we are interested in the positive case, not the negative case so much. And that's why using the positive case, we can create two very important evaluation metric, which are called precision and recall. Let's understand what are those. So first we are starting with the precision, where we take the true positive prediction and then divide it by the total positive prediction, which is this 5. So therefore this axis is basically around the prediction. Like we said, this is the prediction column. So the positive prediction columns and the positive prediction itself, the true positive itself along this axis is basically representing you the precision. And now you can understand that although our accuracy was 60%, the precision is actually 40%. That's how we are interested, and this is more precise in terms of understanding how the positive predictive value, the another name for precision, or how is the quality of the prediction. That's what the precision is telling you. Now we are moving to another evaluation metric around the same thing, which is positive class. But now we are interested about correct. The numerator remains same, but the denominator gets replaced by the actual positive class, not what is predicted, but around this axis, the row positive class. So the actual positive class, okay, will be the denominator this time. And what it is telling you, in this case, recall is more than what accuracy have predicted, right? It is telling the true positive rate, another name for recall, and also it is known by sensitivity. What it is telling you is the coverage, how many out of the total positive sample we have been able to successfully detect. With respect to actual, this is with respect to prediction. So that's how we should remember the precision and recall. And recall is very important to understand what time a product is performing well, or a product actually should be launched in the market, but you want to recall them because there is a danger. And that's how the name recall comes into picture. Okay, we want to understand through this visualization the reason why it is called recall. Let's say there is an obstruction here, and there is a car which has a automated feature which can predict whenever there is a crash, just before the crash, and then it eject the human with an airbag or a balloon, whatsoever, right? So the prediction, the job is to correctly predict that this is going to be a crash or it is a crash, and therefore before the crash actually has happened, you should eject the people. So that's what we are presenting here. Crash happened, and then this man is safely ejected, just with a proper timing. But then prediction is correct here, therefore the true positive is 1, false positive is 0, there is no false positive. Precision becomes 100% because TP by TP plus FP, in this particular cases FP is 0, so it is 100%. And safety for this prediction is also, I am marking it as 100. But we could improve it. Somebody said that why go so close? Why can't we eject the man just before, sometime before? This is too early, but still I think to increase the prediction, they predicted false prediction, false positive. So what we are understanding here, by predicting a false positive, we are not compromising safety, actually we are increasing, but the precision is dropping. This precision can harm the company's revenue, it could be costing them more, or it could be also a matter of inconvenience to the user. So therefore you can see the precision and safety, the contradiction between these two. So this company said that why so early, let's go little closer, and again did so. So then out of these 3 cases, one was true positive, this, and 2 times they have predicted negative. So the precision came down further from 50% to 33%, but still your safety is 100%. Now the company says and realizes that this is really waste, so why don't we change this prediction? He don't actually eject this time. He said that maybe at this time I can declare this as a false negative. Instead of telling this as a false positive, I can actually say that this is false negative, meaning there is no crash. Fair enough, precision increased, safety still is 100%. He became greedy. He said, no, not here, let me become little close and still do negative, still say that this is not a crash. In reality, what has happened, this time it was true negative, this time a little crash has happened, have not harmed the people, but the false negative has increased. Because this is actually positive, because crash has happened. So therefore the precision still is 100% because F is 0, but your safety has come down 50%. Maybe this is okay, they become more greedy and the crash happened and the impact becomes so high that it has harmed the people, the human. And that is why, and that's the time when your safety has reduced, because you have not predicted anything as true negative, both became false negative, and that's how your safety has reduced to 33%. And possibly in between these two there is a value where the company should decide that I need to recall those cars because there is a manufacturing defect. I need to retrain my model and score my recall in a manner so that maybe between these two the car should stop somewhere and then eject the people. Although it is an inconvenience, the safety of the life, safety of the human is important, and therefore it's a time to recall this. So I hope with this illustration you are getting a vivid picture which will help you to remember the purpose of recall and precision lifelong. Let's go forward and see that if they are so important, I want both of them to be high. How do I make that happen? Could I take the average? You see there is a danger here. A danger is that if one is low, arithmetic mean of both this precision and recall still could be high, not reflecting exact picture. For example, here the recall is completely 0, but still the average of them, both of them, is 50%. So this arithmetic mean, the normal average, is not good enough for ensuring or balancing that both precision and recall is at a reasonable state. What could we do? Could we implement the geometric mean? Because this is a multiplication, if recall is 0, it will serve the purpose. The product of recall and precision will become 30% if one is 90% and another is 10%. Could we make it more prominent? And that's where your harmonic means come into picture. Geometric mean is normally good when there is a something which multiplies over time. Harmonic mean is very appropriate for our case, where we want to ensure that there is no significant difference between the precision and the recall. And you can see that when it is the case, your final score is getting penalized more than the geometric mean. This was 30%, this is 18%. So I think this is our case, right? Greater weight to smaller number, even lower than the geometric mean is what we are observing here, tends to be closer to the smaller number when there is a significant disparity between the two values, is what exactly we need. And it punishes extreme values more harshly than the geometric mean. That's why this is preferred over geometric mean. And you also see the calculation over here is basically a reciprocal of the average. Here it is precision plus recall by 2 is the average. Here in this particular case it is exactly reciprocal, 2 by precision plus recall. Often used for average of ratios or rate of average of rates. This is where it serves very well in other cases. And why the name harmonic is coming from the harmony in music, that word, which basically relates to the frequency of notes that sounds pleasant together, and the harmonic are basically harmonic division of the interval. That is how this is coming. This has been inherited from there. Fair enough. A more generic equation for the harmonic mean is basically a beta, where when the beta becomes 1, it is nothing but the F1 score which you have displayed before. But when your recall is more important, we can make the beta more than 1, and that time it will emphasize more on the recall than the precision. And when it is 1, it is exactly opposite. Precision will be given more importance, like spam detection. How exactly you implement this? Through the machine learning libraries like sklearn. You can see they have provided you F1 score and F beta score, two different scoring mechanism. And if you see that how do you apply F1 score, basically you pass on the label and the actual prediction to get the F1, and similarly for F beta you pass the same thing, label and the prediction along with the beta value, which will be more than 2, so it will emphasize more on the recall. Now the time has come to go to the multi-class and application of this confusion matrix in the multi-class scenario. Here we have this different classes A, B and C. There are 3 classes. This is what is the sequence of word. Let's say it is an NLP application, and we want the sequence of words to be predicted in this manner. First is A, and the prediction from here is also A. Very easy to understand that this is true positive. But then what is negative here? Negative is all other classes, and this is what we call it as a reference class A. With respect to A, all other class B and C are negative in this. The next prediction is A, although the actual label is B. What would be the result for this one? The result is false positive, because you focus on the prediction. It is predicting A but false, so therefore you should focus always on the prediction. This is what prediction it has done. It has predicted a negative class. What is the actual class? True. So therefore this will be true negative. You are predicting again a negative class, but what is the actually say? Therefore this is going to be the false negative. So how do you calculate a true positive? It is going to be the number of times the positive class or the reference class has been predicted correctly, which is 2 here. So similarly, number of times the positive class has been predicted incorrectly is the FP, and together you can give they can create the precision. Similarly for the false negative, you count the number of times and then calculate the recall. Let's do it once more for when the class is C. Okay, there will be something new here, so let's understand that as well. What is happening here, that your C class becomes positive and all other class with respect to the reference class C becomes negative, which is A, and this is wrong typo, this should be B. All other letters, which is A and B in this case, are negative and C is the positive. Fair enough. So what we see here is that A predicted, we know this is true negative, correct? Easy to understand. What is important here to identify this? What in your opinion is going to be this prediction? This we should label. Is it a true negative or is it a false negative? Well, this is a true negative because you are predicting a negative class. Although it has not matched with the label, but the way you should identify always that this one true in the sense that it has correctly identified that this class is not C in both places. In one place where the predict other class correctly, another place where predict other class incorrectly. But both places what is correct is that C is not the prediction. Therefore both are true negative. This is some subtle difference which you should keep it in mind. This is true positive, so we can quickly skip through this. This is false positive. There also is okay false positive because we have predicted positive class. Now you understand more clearly the false negative, which is this place. You have predicted A in place of the positive class, right? So this is negative, but it is false because the actual class is C. So it should have identified C because it could not identify it, see here, it has failed to detect the positive class. It is a false negative, as opposed to A and B, where it has correctly identified that it is not C. Therefore, this is a true negative. So this is what rest of the things are same. So I'm skipping very fast. A minor difference, a subtle difference between Tn and Fn in a multi-class scenario, what you should remember. Fair enough. Now let's go through a code snippet. How do you do the how do you apply the confusion matrix concept and calculate the precision recall for a multi-class scenario is basically by these two libraries, which is classification report and confusion matrix. So what we have done here, we have just created a mock data set. Important stuff here is the y-test, which is our level. We have created a random forest classifier, trained the model, and then trying to predict. So this becomes my prediction values, y-pred, and this is my level. And that when I pass it to a confusion matrix, it will give me the confusion matrix. And same thing when it is passed to classification report, will give me precision recall and the F1 score, all three of them. Here it is today. Now, like we said, that the way we had structured our confusion matrix is aligned with the code, which means that all the rows are actual and all the columns are prediction. For example, so therefore this column, first column, is basically prediction of class 0. Just to test it out, you can see that this is the class 0 true, this is the prediction 0 true. So TP in this case is 15 and FP for class 0 is 0. So therefore class 0 FP is 0 and the precision is 1, matches with our expectation, right? And the total, which is 15 plus 1, 16 plus 2, 18 are the total number of actual value which is represented here. That's how we should interpret the classification report. We test it out for class 1, in which case this is the class 1, where we can see the prediction, true prediction is 82. I have presented here class 1, and the false prediction is 1 plus 0, 1. So 80, again there is a mistake here. This should be 82 plus 1, 83. So this is 98 point some values, rounded up to 99% is presented here. Let's take another one. You see the third one, this one, which is 96. How it is coming? 146 is the TP. These diagonal lines are all positive. 146 plus these are false positive, 2 plus 6, and you will get to this number. If you go to now recall for class 0, we can, as we know that this is not, this time we are interested in false negative. So the false positive are along this line, negatives are basically column. So 15 plus 1 plus 2 will give it 83. Remember, this is how your confusion matrix and classification report can be interpreted. In the previous thing, classification report, like we said, that these are topics which is not discussed, okay, when the confusion matrix and precision and recalls are introduced in the tutorial, most of the tutorial or academic literature, etc. These are very granular level of details, class wise precision recall, but what is the average of the model, how it is performing on an average? That's why we take up this help of this macro average. Macro average is very easy. Basically, whatever precision has been predicted, we just take a average of this. Whatever recall has been predicted, we take a average of this, right? 83, 95 and 1 divided by 3 gives you the average of macro average for this one. And so is for F1. We take the average of this F1 score. What is more accurate representation is the micro average, where we know this diagonal values are representing your true positive. For example, if this is 15, this is the true positive for class 1. If this is 82, this is true positive for class 1. Sorry, 15 was for class 0. this is for class 1, but 15 at this time with respect to class 1 is true negative. 146 with respect to class 1 is true negative, but when I am measuring it with respect to class 2, then 146 is TP, true positive, and these two are true negative. And anyway, so these are basically all true values, true positive values. I am taking summation of all of them, and then I want to calculate all the true positive. Can you tell me how do you calculate that one? Yeah, you are right, because now I know positive are basically this column. These are the prediction for this class. So I know for this particular class of class 0, I have no false positive. So 0 is the false positive. For the class 1, this column is saying that there is only one false positive. So that's a 1. And for the last two, there are two false positive, which is this. That totals up to 7. False negative, can you tell me now? Yeah, they are basically along the row. So if this is 15, and if it is false negative column, because this is positive, so I'm doing a false negative prediction here, and 1 which is actually belonging to class 0, but I have said him as negative, which is a positive class, or it's a class 0. Therefore this row represents the false negative, and we know for the class 15 for all class is 1 plus 2 for the first one, the second one is only 4, and the third class is for the 146, sorry, for the 0, both are 0. So this is also 7 coincidentally. Now I can utilize this TP, this FN, and this AP to calculate the average precision, micro average precision, and the micro average F1. In this case, the precision and recall will be same because the P is equal to Fn. There is one more which is called the weighted average, which is written here. This is nothing but the values weighted by their total number of examples which is present. For example, if we do precision, then we know 1 has 18 number of examples, so the weight is 18. I am multiplying with that weight. 99, which is weighted average precision, 99 is supported by 86, so this one, and then 96 is by 146. So that's how I am calculating the weighted average of precision. I do the same thing for recall, 83 into 18, and 1 into 146, matching here. And then weighted average of F1, I do the same thing, 91 into 18, and 97 into 86, and 98 into 146. That's all about confusion matrix and the precision recall calculation, F1 calculation for balancing either the positive or the negative class ratio, and then finally applying them in a multi-class scenario. See you in the next tutorial.